Okay, here in our 2-2 ACP review, number 1 says this. Which of the following is not a solution to y is greater than negative 3/4 x plus 2? And by the way, guys, these are the actual problems that are about to follow this video. So I'd encourage you to go try these problems first and then come back and only use the video to A, check your answers, and B, go ahead and see which problems you actually need help on. Alright, so let's take a look at 4, -1. Well, if I label 4, -1, x, comma, y, I'm going to plug this in. So I'd say that my y value is -1 is greater than negative 3/4 times x, which I see here is 4 from that answer choice A, and then I write plus 2. Now let's go ahead and evaluate this. So -1 stays the same, and here negative 3 over 4 times 4 over 1, well, negative 3 times 4 is negative 12 over 4 times 1 is 1. Oh, I'm sorry, 4 times 1 is 4 plus 2. Now right here we have -1 is greater than, and negative 12 divided by 4 is in fact negative 3 plus 2. And -1 is greater than, negative 3 plus 2 is -1. So the question becomes, is this a true or false statement? Is -1 greater than -1? And of course that's a false statement, so we know that we know that A is not a solution. Let me write that, not a solution. Okay, and actually I apologize, we are looking for the one that is not a solution, so the correct answer is in fact A. Disregard that X. We're looking for which to the following is not a solution. The answer was A. Alright, now if you'd plugged in the rest of these, you would have gotten a true statement, which means that they would have been solutions. Moving on to our next one. Okay, number 2 says find the solution to the equation below. So we have -18 is equal to negative x squared plus 7. Well, what are we going to do to get the x squared by itself? Well, we can subtract 7 from both sides, and I believe that shows up pretty good on y'all's end. And -18 minus 7, of course, is -25, is equal to negative x squared. Now, my fear here is that a lot of you don't exactly understand what a negative variable is. That is just saying -1 x squared. So if I want to get x squared by itself, I simply have to divide both sides by -1. Now, negative divided by negative is a positive, and 25 divided by 1 is 25. From here, I can take the square root of both sides, and we know that the square root of 25, well, that breaks down into 5 and 5. There's our pair. Well, we would say that x is equal to 5. Now, one quick note. This is actually not 120% true. This graph is actually going to look something like 1, 2, 3, 4, 5, 6, 7. This graph is actually going to look something like, something like this, okay? In fact, it's going to be a little bit different than that, but just know that somehow, some way, there's actually 2 solutions here. There's a positive 5 and there's a negative 5, but just for right now, we're focusing only on the positive solution. Okay. Here we are in our third example. Which of the following inequalities best represents the graph below? Well, guys, you always should start here at your y-intercept, and we see that our y-intercept, our b term, is in fact at 2. Now then from there, what I would always do is I just follow my pencil along until I hit the next perfect point, and see here, a perfect point is where a vertical and a horizontal line both cross, and our line meets that point. Okay, so what is our slope? Well, that's the change in y over the change in x. So we're saying, okay, from here to here, we know that we went down, let's see, 1, 2, 3. So we went down 3, and we went to the right. We went to the right 1. Well, what are we really saying? We're saying down 3 is -3 over, going to the right 1, positive 1. Our slope is -3. So when you look at the formula y equals mx plus b, and we have this, we have y something, and our m term is -3x plus 2. Well, now we want to look at this line and ask, is it dotted or solid? And since it's dotted, we know that it's not going to be an equal to symbol. And you see how it's shaded below the line? Well, that is less than. Alright, I hope this helps. Let's move on to example number 4. Okay, example number 4 was actually a problem from the most recent test, and it was one of my most frequently asked about problems. So I want to help y'all out with this one. So notice here, this is not being asked to be distributed, so I'm going to write AB cubed. But here I have a negative 3 times 5 over 2. Well, recall that's really negative 3 over 1, and negative 3 times 5 is negative 15 over, and 1 times 2 is 2 on the bottom, x squared. Now from here it's a little bit easier. We know negative 3 times negative 4 is positive 12ab cubed. We know negative 3 times 5, remember we're just distributing, is negative 15. And then we drop the minus 12 plus 6x squared. Now, I kind of went and I kind of cheated with y'all on the test. I had you only look at the AB cubes. Well, we know this is a 1ab cubed plus a 12ab cubed is 13ab cubed. And there was only one answer choice with 13ab cubed, so we stopped right there. But notice our x squared term actually has a fraction, and this x squared term has a fraction as well. And I want you to recall, I always want you to do your fraction work off to the side. So let's just write this, negative 15 over 2 plus 6, and let's change that to 6 over 1. Well, the question becomes, can I multiply 1 by some number to get to 2? And we know that 1 times 2 will get us to 2. And what I do to the bottom, I do to the top. Okay, so now I've got negative 15 over 2 plus, and 6 times 2 is 12 over 1 times 2 is 2. And guys, negative 15 plus 12, we add what is on the top. Negative 15 plus 12 gives us negative 3 over 2. And so I'll even write that in the gold, minus 3 over 2. And then we can switch back to this other color, x squared. And lastly, negative 15 minus 12 will give us negative 17. All right, y'all. These 4 examples comprise the following review questions. I hope that you actually tried the questions first and you didn't just copy answers. And I'll see you guys in our next lesson.